Good morning, sixth graders. It is April 16th, 2020. It is a Thursday morning and it is YouTube video day with Mrs. P at West Platte Elementary. Today, we are going to start a new chapter, not a new unit because we're still dealing with algebra, but we are going to start a new chapter. It would be technically chapter 9. Parents, if you're watching this with your students, we are starting chapter 9 in our Go Math series. I should flip back to the table of contents. Chapter 9, which talks about algebraic relationships between variables. We just left chapter 8, which talked about algebra, equations, and inequalities. And before that, we had done chapter 7, which dealt with expressions in algebra. So all of it dealing with algebra. And so this is really our last chapter in algebra, chapter 9. It's going to be the most extensive chapter in our unit on algebra because we're going to now start talking about algebraic relationships, meaning we have now introduced students from going numerical expressions, numerical math problems, numerical math statements, sentences, to algebraic math statements or sentences, introducing and including variables, something that's missing in the problem. But the fact is, your students have been doing this all their life. I mean, I'm just honest, and they know it. When the teacher in K or first grade came to your students and said, I have 7 apples here in this bin is empty, but if there were apples in this bin and I put them together, they would equal what's in this third bin over here, which is 10. Everybody knows I love using this problem. So what did I just say? I said that I have a bin and it has 7 apples in it. Here's another bin. It has no apples in it. Oh, you can't really see that, can you? Let me move it closer. I'm moving this a lot today. It has 7 apples in it. This bin has no apples in it, but when this bin gets full or has apples in it, they're going to equal what's in this bin, which is 10. Now, your students have been doing this since they were 5, 6, 7 years old. They know if, hey, there's 10 apples in this bin, and it started with 7 apples in this bin, how many apples do I need in this bin to get to 10? 3. And I add them together. That's algebra. I know it doesn't seem like it, but it is. Because what I could have done is I could have taken out the 3 apples and said 7 plus A equals 10. First graders, what is A? And they would have just told us it was 3. So we moved from this 7 plus 3 equals 10 notion of numerical mathematical statements to algebraic statements, which now we have to have some relationships between those. As you see here, the relationship is that 7 plus the variable A is going to give me 10. Well, what happens if there's more than one variable in my problem? What happens if I'm missing more than one piece of information? And that is what chapter 9 is going to be about. So let me erase this and let's get this party started. And it is to me, math is. It's the most fun in the day at school. Math, to me. So, we're going to talk about algebraic relationships. And that starts in chapter 9. I wanted to finish showing you this. Chapter 9. Again, curriculum are our standards. They are the things that we give. They are the components that we give students that state in the state of Missouri and across the United States that a 6th grader, 11 or 12 years old, can learn these components, these concepts in mathematics. That is what curriculum is. That is our goal, our end goal as an educator, as anyone in the state of Missouri who's teaching education, is for us to see if our sixth graders can achieve, set a goal for themselves, and achieve success within themselves by learning these concepts in mathematics. So the concepts we're currently working on in chapter 9 are algebraic relationships. Can students tell in an algebraic statement, an equation, an expression, how things relate, how this one thing that's missing is going to relate to this other thing that I need to solve? That's algebraic relationships. That's in chapter 9. The reason I'm explaining that is that's curriculum. That's what curriculum really is. Can students do these things? That's our end goal. It's no different than you in life. Your boss gives you a job, and can you then achieve that goal? In Missouri education, we want to see if students can understand and achieve the goal of algebraic relationships. Can they see a problem that's missing something, and can they go about doing different experiments or exercises or trying different solutions that will give them a response? And if it doesn't, can they go back and try it again? What we use are resources. This isn't the curriculum. This is a resource we use to help guide the students and assist the students in obtaining the curriculum, in helping them learn and gain the knowledge on the curriculum. So this is the resource, and chapter 9 in the resource starts on page, I keep going from one too far to one too short, starts on page, ladies and gentlemen, students and parents alike, page 491. Now, what I'm going to be doing today is not introducing a particular lesson, but the concept that we're going to be going over in chapter 9. And then when I meet with the students all next week, that's when I'll be picking up a certain component that I'll be focusing on and working on them with. So, long story short, these are the concepts, this is what curriculum is called, that I would love for the students to gain a little bit of knowledge on. Students, I want you to have this set in your database, that you've heard this, that you have looked at it, and that you're like, oh, I can then keep learning about it, and I can also talk about it. Whether it's, I get it, I have it, 100% I understand it. That's not what I'm asking for. I'm asking you to acknowledge it, and then be able later on to maybe talk about it, so that we can build upon it and extend upon your knowledge so that you feel more comfortable when you head into junior high. So, algebraic relationships, coming from, and I probably should have wrote that on there, coming from chapter 9. It starts on page, what did I just say, 491. So that is what this YouTube video is about, algebraic relationships. So the first thing we have to ask ourselves is, how do variables in an equation relate to each other? And that's the little problem I just did. 7 apples in a bin, no apples in a bin, but they need to equal 10 apples in a bin. What's in that bin that's going to relate to that 7 and 10? Well, we just said, what's in that bin? 3. 3 related to 7 gives me 10, because 7 and 3 equals 10, and 10 is 10. And if I don't put 3 in the bin, can I put a variable in the bin so that the students can find out what should go in the bin? The process of figuring out the unknown. Algebra. So that's that relationship in that particular problem. But now we need to have students start focusing on what happens if you get something in algebra that a couple of pieces of things are unknown and missing. What do? Well, we now need to acknowledge that these things called variables in some algebraic problems are going to have specific names. We are now going to work with 2 types of variables. Before any variable, any letter that's placed in a mathematical statement is called a variable. But if we create an algebraic equation where one variable is doing something and another variable is doing something, you have more than one variable in that problem, we are now going to give them specific names. One is going to be called and I have to make sure I'm going to say this right, independent and dependent. Now, these two names are not new to students, especially not in the 6th grade. Why are they not new? At West Platte, they're not new because Mrs. Frost, their science teacher, has been using independent and dependent variable in science experiments with them all year. So they know the words independent, dependent. They know when they hear them. Now they have to figure out, what do they really mean? Well, I always like starting off with the students by saying, hey, independent and dependent, let's just break them down grammatically, as in, what is their meaning in the English language? If I'm independent, and this is where 6th graders normally start saying this word, I'm going to be very independent, mother and father. I'm going to junior high next year. Can I have a little bit more freedom, a little bit more responsibility to do what I want? I want to be independent, mom and dad. I want to be able to do stuff. Independent is on your own. You're not dependent on anyone except your individual self. So I always like using those kinds of little mnemonic devices to help students. Independence means that you are not dependent on anyone except your individual self. Individual starting with I-N, D-I-V-I-D-I-N-I, D-I-V-I-D-U-L-A. Okay? Individual. So individual starting with I-N, meaning you're not dependent on anyone except your individual self. Independent means that these things are set by you. Your bedtime, I don't mean this, parents, unless you want them to. Your bedtime, you want to set. I don't want to go to bed at 8:30 anymore, Mom. I want to go to bed at 9:30. That's you independently setting your bedtime. You are doing that. You want the power to change that. Dependent is mom and dad are going to tell you no. You're still going to bed at 8:30. Why? Because you are dependent. Dependent. I am depending, grammatical root word of depend, depending on someone else to help do things for me. My mom and dad put a roof over my head and feed me. So if they tell me to go to bed at 8:30, I'm going to go to bed at 8:30 because I am dependent on them for a roof over my head and food on the table. So they are going to control me. They are going to say what the outcome is. So you are dependent on them, and a little bit of them being dependent on you. If it wasn't for you, they wouldn't be setting a bedtime. So they're waiting for you. They couldn't wait to have you. And then they had dependence over you. You were dependent on them, so they, of course, had their dependence on you. Because then now you're their child and they have control over you. So that's the kind of way I like to describe independent and dependent for the students. Look for it grammatically. Look for it with English language. What do we really think these words mean? Well, independent means it can be ever-changing. If you're independent and you are driving a 2010 Ford Explorer and you want a 2020 Ford Explorer, it's independent on you to make the money to go get that new Ford Explorer. And that means you can change it. It's ever changing. But if you're dependent on mom and dad for that money, whatever you do here and however they control that is going to be that outcome. So what happens and goes on in the beginning is going to determine what is the outcome at the end. And that's what we're leading to in this unit of study with algebraic relationships. How can I see a variable in an equation and then know Which one is dependent on who? And what is the outcome going to be? How do I know to tell the difference on that? And that's this whole unit of study that we're going to be talking about this week with the students in the month of April, while we're doing online instruction. So algebraic relationships, how do we tell, or how do variables in an equation relate to each other? Well, one is independent and one is dependent. This one is going to depend on what's going on up here. If mom and dad didn't have you, then there would be no dependency. They wouldn't have to tell anyone when to go to bed. I mean, that's just the fact. So you are not independent until mom and dad give you that dependency, release that dependency over you. So I'm going to do a quick example of just one of these in an algebraic format. And then I wrote a word problem on the back of this. I told you I'm going to be moving this board around a lot today. So I'm going to just do one of these problems. I'm trying to not get the glare of that sun, but it doesn't seem to work very well. Excuse me. Sorry, I'm off camera. I still think I'm going to have the glare. Yeah, just where I'm setting. So I want to just show you a problem where we talk about these variables and independent dependence really quick. And I want to show it to you in a format and then determine how things would happen. So what I'm going to show you in an algebraic equation, really quick, you're going to notice that in the very beginning, you are trying to decipher. That sun is so bothering me. Isn't it bad how picky I am? In this equation, you're going to have to decipher what information you see. So let's just start with one that looks like this. Y equals x minus 7. Now, if I were to give the students this algebraic expression, this algebraic equation, right away they'd be like, I don't know what these variables stand for. They, again, here in this instance, it's like an expression. Do you want me to answer it? Do you not want me to answer it? I don't know. So, in this instance, they could make x and y anything they wanted. Oh, except that if they made x something, then y is definitely going to be some sort of outcome. So, since this x could be ever changing, can I change x to anything I want it to be? It will be what is known as the independent variable, because I can change x to anything I want to. Right now I can. I want x to be 9. And if I said x is 9, then what is y? Well, y cannot become anything until I say what x is. So that is why, isn't that funny? I'm getting ready to say it. That is why y is the dependent variable. This is the independent variable, and this is the dependent variable. And another way I like to help students recognize that in equations is independent is like the input. Hopefully, and I've used this with the kids before, they've seen a thing known as the input, and I should put this the other way. Input, output man. Something goes in, something comes out. And I've kind of used that with just humanity itself. Something goes in, something comes out. So if I said x goes in, and when it gets in here, I'm going to take 7 away from it, something is going to come out, which in this case will be the y. X goes in, I take 7 away from x, out comes the y. This is independent because I can make it anything I want it to be. This is dependent because it's waiting to happen after I put the x in. That's the relationships of algebraic variables. How do I see or tell algebraic relationships? How do I know what variables in an equation mean to each other? Well, one is independent. It can do anything, which is what kids want, but we're not quite there yet. Two, dependent, which means I can't do anything unless somebody tells me what to do or gives me something to do. In this case, I'm going to give you X. I want Y to come out, and the only thing I want you to do to that X is take away 7. So, as I use down here, if I put in 9 and I take away 7, out comes 2. So in goes 9. What happens to it? This is my equation. X minus 7, that's my equation. I put in something for my independent variable known as 9. And out comes 2, which is known as my dependent variable Y. So in as X, out as Y. And it doesn't have to be an X and a Y. It just has to be a variable that is dependent on something else happening independently, the change. So that's what our lovely next chapter in our unit of algebra is going to be about. And then we're going to do more on Zoom, more on YouTube, more on Zoom, more on YouTube next week on Monday, Tuesday, Wednesday, Thursday, and then Friday we'll move on to something else. Now, parents and students alike, don't start freaking. Mom, she's at 21 minutes. And she said we're going to just talk about that this week. How can that be? Remember, at the beginning of this video, I talked about this is just an introduction to your students. We are on lockdown in our country, in our state, so we cannot be together in a classroom. They're not going to get as much from me over a 20 or a 30-minute video about algebraic relationships. What I do want is to give them an introduction into it so that then their mind starts thinking, what can I do with this? What more can I learn about this? That's what we're searching for while we're on this online instruction. For students to ask themselves, what else is there? Mrs. Pease gave me an introduction to it. Now what can I do with it? Where do I take it? And so this is the introduction. We're going to start talking about algebraic relationships. How do variables in an equation relate to each other? We're going to start learning about 2 of them, known as independent, dependent. 2 variables, in this case an X and a Y. How do we know that one is independent? How do we know one is dependent? By looking at what Mrs. P loves to call the input-output man. Something comes in, something has to come out. Your paycheck goes in your bank account, mom and dad, students, and your kids want a new Xbox game, something goes out. My independent check can change. My amount of money can change that goes in. What comes out and what I'm left with is going to be absolute unless my kid comes and asks me for a new Xbox game when I'm trying to pay the electric bill and the water bill. Those are real unknown circumstances in life known as algebraic problems. So I'm going to leave you with one I wrote on the back of the board, if I can spin around without knocking a whole bunch of stuff over. So here's going to be something in real life, and I used one of our lovely family members because I think it would be very relatable to her life, her children's life, and a lot of us in the community, because a lot of us love what this lovely lady does. So today I'm using Mrs. Galloway in our word problem. My word problem says that Mrs. Galloway goes shopping for farm fare, her lovely eatery. Good food. She goes shopping for farm fare, and I hope you don't mind me using you, Mrs. Galloway. Mrs. Galloway goes shopping for farm fare. At the market, apples are on sale for $1.99 a pound. $1.99 a pound. Miss G, Mrs. Galloway, buys P pounds of apples for a total cost of C dollars. Now, this is our word problem. So the students know with Mrs. P, the first thing, and it's not something Mrs. P invented, but I do like them to use it. It would be something I should have invented. The first time we read a word problem, we just read it to be reading it. We just read it, like you read a book. You read it, then you go back. I want to read that book again. It was so good. I want to learn more stuff about what was in the book. So I've read the word problem once, Now I'm going to read it again, and in this case, when I read it again, I'm going to start thinking about the stuff that I see in it, or that I hear in it, that might mathematically explain something to me that I need to solve, or maybe it's already solved, I don't know. But since we're using algebra, we're probably looking for something that's not solved and that I want to solve. So I'm going to read it again, and when I read it again, students or parents alike, I want you to start thinking about things you hear in the word problem that you need mathematically. Okay? Mrs. Galloway goes shopping for farm fare. At the market, apples are on sale for $1.99 a pound. Miss G buys P pounds of apples for a total cost of C dollars. Okay, now that I've read it twice, I tell the students, third time. Now, when you read it for a third time, this is where many of teachers would have told you, start underlining and circling information. And I'm no different. You need to pick up what's important, okay? It is the information you need in order to give someone a solution to their problem. My friend is crying. She tells me what's the matter. Input. What can I do? Output to help her solve that problem. Math is no different. So, Mrs. Galloway, we love you, Mrs. Galloway. We love farm fare. But when we're thinking about math, Mrs. Galloway goes shopping for farm fare. Is that information, are those words important for me to solve the mathematical problem? No. Instead of Mrs. Galloway, I could have picked Mrs. Lewis, Ivy's mommy. I could have picked Miss Jeffers, Olivia's mommy. And they could have went shopping for their home. So that information, although in the problem, is not the important details. They are details. So if someone came up and said, well, who went shopping? Then that would be an important detail. Who they go shopping or what they go shopping for, farm fare, then that would be important if that's the question they were asking. But that's not the question in this problem. The question is that Mrs. Galloway goes shopping for farm fare. At the market, apples are on sale for $1.99. Is that important information in this problem? Well, yes. At the market, I don't really care if it's at the market or not. Maybe it's at the grocery store, wherever. But the apples on sale for $1.99 a pound. Sorry, I'm using this slightly. I'm not supposed to use this on paper. Apples on sale for $1.99 a pound is very important because it tells me how much the apples cost. Hear those words I just said? Apples are on sale for $1.99 a pound. That tells me the cost of the apples per pound. That's very important information for me to know. It then goes on to say Mrs. G, again, love Mrs. G, but is she important for me to do my mathematical work? No. But what is important that Mrs. G does is Miss G buys P pounds of those apples. Well, how many is P pounds? Well, we don't know. Mrs. Galloway didn't tell us how many pounds of apples she was buying. She just knows she's at the market. She knows the apples cost $1.99, but she hasn't told us how many pounds she has bought yet. So, Mrs. G buys P pounds of apples, and it goes on at the end of the problem to state that the P pounds of apples are a total cost of C dollars. Now, do we know how many C dollars is? Again, we do not know. We do not know. So, we have now discovered two things we do not know. We know that Mrs. Galloway bought apples for $1.99 a pound, but we have no idea how many P pounds she bought, nor do we know the C total cost of the apples. The only thing we do know is that they cost $1.99 a pound, but we don't know how many pounds she bought, and we do not know the total cost of those apples. So when we're studying this week, this unit, I'm going to ask the students to look for some things like this. Students, out of this word problem about Mrs. Galloway going to the market for farm fare, the details that you located, that you underlined or circled, can you now tell me, is there a mathematical statement that you can write from this word problem? Is there something you can pick out and make a mathematical statement, a sentence about? Well, I know that apples are $1.99 a pound. So I'm going to start with, I know apples are $1.99 a pound. And that's fantastic. $1.99 a pound, again, a glare. $1.99 a pound. Do I know the next piece of information, how many pounds Mrs. Galloway bought? I do not. I do know they cost $1.99 though. So if I was buying some pounds of apples and I knew they cost $1.99, what mathematical operation would I use in telling me how much those pounds of apples cost? Would I take $1.99 and add p to it? Would I add $1.99 plus 3? The 3 pounds of apples? $1.99 plus 3 pounds of apples. Would I do that? Oh, probably not, because $1.99 plus 3 is, am I just adding the 3 to the 9? The pounds are not in the same unit of measurements as money. So what I want to do is find what mathematical operation I would use. Doesn't sound like adding would work. Do I want to subtract the pounds of apples? Probably not. Do I want to divide the pounds of apples by $1.99 or $1.99 by 3? Did the 3 pounds of apples only cost $1.99? Or did every pound of the apples cost $1.99? I think every pound of the apples cost $1.99. And as I said that, I feel like I'm saying, it's a beautiful day in the neighborhood. I feel like I'm being Mr. Rogers. $1.99. So this is a part of algebra, really mathematics and life, that we're wanting students to work on when it comes to academics and curriculum. Start talking about what's going on. Start talking about how are you going to figure this stuff out. Well, that's what I just did internally to myself, but externally to show the students. It's $1.99. I don't want to add it. I don't want to subtract it. I don't want to divide it. I talked about all those. Those didn't seem like they would be the best mathematical operation. So the only one I have left is, I wonder, should I multiply $1.99 by pounds? And in algebra, students know they can put the variable right by the number. So I'm going to put $1.99p. And if I say $1.99 times p, what is that going to equal? Well, it's going to equal my total cost that Mrs. Galloway spent at the market on her apples. Now, I don't know what P and C is, but I do know that that C out there, how much Mrs. Galloway spent as a total cost, is very dependent. It's dependent. This is my dependent variable, which I went ahead and wrote down here for you. Why is C dependent? Because I can't tell you how much the apples cost until I know the independent P variable of how many pounds of apples Mrs. Galloway purchased. That's how we see the relationships in algebraic thinking. If I find out that Mrs. Galloway bought 3 pounds of apples, I then can tell you the cost. But until I know independently how many pounds of apples she purchased, I won't be able to dependently tell you how much she spent. And that is what we're going to be learning this week in 6th grade mathematics at West Platte Elementary with Mrs. P. Pretty long video, 35 minutes, but hopefully your students have a better understanding of what we're going to talk about, and they'll be willing to engage in that and not stressed if it doesn't work, and they'll go back in there and try it again. Just remember, we're listening to gain extra knowledge. That's it for today, as I think the delivery man is coming to my house and ready to ring the doorbell. Until next time, have a great day, have a beautiful weekend, and I'll see you all back on Monday. Love you bunches. Bye, sixth graders.